In this example, we're starting with an alkyl halide and we're trying to synthesize an ether. So we're going to use a couple of steps here. First, we'll just do a standard nucleophilic substitution to get an OH group here, and then we can take advantage of the Williamson ether synthesis. So what we can do first is treat this alkyl bromide. We'll just do sodium hydroxide to affect an SN2 reaction. That gets us an OH group in place of the bromine. So that's how we install this first oxygen, which is going to make up our ether. But now we need to do the steps for an ether synthesis. So first we need to turn this into a good nucleophile. So step one, we'll treat this with a base. You could use sodium amide. In this case, I'll just use sodium hydride. A plus, H minus. So now our basic H minus will attack that acidic proton, giving us our intermediate. Which has an O minus, so an alkoxide. And then we have the countercation Na plus. And then during that process, we generate hydrogen gas. So now that we have this good nucleophile, our second step of the reaction can be reacting this with an alkyl halide to install this ethyl group. So we need an ethyl group attached, so we'll use an ethyl halide. So let's just do an ethyl bromide in our second step. So now it's basically just another SN2 reaction. Here's our nucleophile. We attack our electrophile, kick off the bromine. That allows us to install this ethyl group onto the oxygen. So now we've successfully synthesized our ether.